Hey guys, welcome back. Today we are going to implement an interesting use case in MapReduce. This project that we are going to see is inspired by the common friends functionality that you see in Facebook. When you're looking at a friend's profile, Facebook will show you the common friends that you and your friend have in common. Ever surprised to see a common friend in the list and wondered how your friend know the other friend? It happened to me a lot of times. We included this project in the course because it teaches how to take an abstract problem like this and implement the same in MapReduce. And second, we are going to write some simple custom writables. Let's start by looking at what this project will achieve. Let's say we have a data set like this. Record number 1 will have a person's name, a tab space, and his list of friends. Record number 2 will have another person's name and a tab space and his list of friends. Similarly, you can have as many records as you want. So here, Tom has 2 friends, Jerry and John. John has 3 friends, Jerry, Sarah, and Tom. So the mutual friend between Tom and John is Jerry. Here is how the actual data set will look like. Each person or friend in the actual data set is represented in JSON format. JSON format is very simple. JSON stands for JavaScript Object Notation, and it is widely used format these days because of its flexibility and scalability. And here's our actual data set. The data set is only 4 lines, and it's a very tiny data set, but you can add as many records as you like to this data set and our program will work. Each person or friend in the data set is represented in JSON format. Let's take a look at this highlighted object. This highlighted object defines a user. And you can see it has a collection of properties defined as name-value pairs. So a person object will have 3 properties: ID, name of the person, and hometown. Then comes a tab space, which is right here, and then followed by a list of his friends. In this case, list of Anna's friends. And each friend in this list is also a person, so they will also have 3 properties: ID, name, and hometown. So here we have few friends for Anna. One is Beth, the other one is Pete, and the other one is Emily, and so on. We'll have the same for each record. So in this record, Don is the person, followed by a tab space, and we have a list of friends for John. Everything represented in JSON format. Now that we know how the data looks like and what we would like to achieve, let's talk about the MapReduce program itself. Now, pause this video for a few minutes. Take a pen and paper and try to work out this problem. You don't have to write the MapReduce program, but write what will be the input to the mapper and output from the mapper, and what is the input to the reducer and output from the reducer. Take a few minutes and do this exercise. Go ahead, pause the video and try it. The MapReduce problem itself is very simple. Let's take our sample input to demonstrate the program. In the sample dataset, we have 2 friends, Tom and John, with Jerry as their mutual friend. In the mapper, we'll read each line as a record. In each line, we'll form friend pairs, meaning in the first record, we have 2 friend pairs. Tom and Jerry is the first pair, Tom and John is the second pair. In the second record, we have 3 friend pairs, John and Jerry, John and Sarah, John and Tom. If a person has 100 friends, you will find 100 pairs. Make sense? Okay. The friend pair will become the key in the key value pair output from the mapper. The value will be a list of friends as an array. So here you can see the mapper's output, and this is how it looks like. Now let's look at the reducer. The trick in the reducer is we have to consider the second and the 5th friend pair from the key value pairs as equal. So take a look at the second and the 5th key value pairs. Tom John and John Tom are logically equal, correct? Key value pairs with the same key will be sent to the same reducer. If Tom John and John Tom are considered equal, they will be sent to the same reducer. And here is how the reducer input will look like for Tom John or John Tom pair. It has 2 set of friends array, correct? One set is Tom's friends list and the other set is John's friends list. Now it is very simple to find the common friend in the reducer between Tom and John, and the mutual friend would be Jerry. That is it. Now that we understand how to implement the solution, let's look at the MapReduce program. But before we do so, look at the key value pairs that we have to deal with in the illustration here. In our actual data set, a person or friend has three properties: ID, name, and hometown. So to represent that, we will need to create a new writable named friend. Now look at the reducer's input. We have a friend pair and then list of friends. So we need another writable to represent a pair of friends. We'll call it friend pair. The value in the key value pair is, and then to represent an array of friends, we'll create another writable named friend array. So we will look at the custom writable objects first, starting with friend. The friend class here implements writable comparable, which makes friend a writable object. The friend class will have three properties: ID, name, and hometown. ID as int writable, name and hometown as text. We'll define constructors and the set and the get methods for each of the property. For any writable object, you have to define read fields and write method. Write method is to write the contents of the writable object to the stream, and read fields is to read the contents of the writable from the stream. Since we are using writable objects already for the properties ID, name, and hometown, that is, we are using int writable for ID, text for name and hometown, we can simply call read fields and write method on those objects. We can simply call the read fields and write method on those objects in our read fields and write method. Next, we'll override compare to, equals, and toString method. For compare to and equals, we'll compare two friends object with the value in the ID property. If the ID is equal between two friend objects, then they are considered same, or they will be considered as different friend objects. That is it for the friend writable object. Let's move on to friend pair now. Friend pair has nothing but two friend objects. We will again implement writable comparable so that friend pair will become a writable object. And in the read fields and write method, we'll simply call the read fields and write method on the friend object, since the friend object is already a writable object. The compare to and equals method are very important here. Remember, a friend pair with Tom and John and a friend pair with John and Tom is one and the same, and they must be considered equal. If you look at the equals method, that is exactly what we do. We'll check whether the first friend in pair 1 equals to the first friend in pair 2 or second friend in pair 2. Similarly, we'll check whether the second friend in pair 1 is equal to the first friend in pair 2 or second friend in pair 2. And finally, we return true if both pairs are equal, or return false if both pairs are not equal. We will do similar logic in the compare to function as well. This is very important because friend pair is the key in the key value pair output from the mapper. So in the shuffle phase, friend pair will be compared with one another and will be sent to the appropriate reducer. And when the friend pairs are equal, we want them to be sent to the same reducer. So we want friend pairs which are logically the same evaluate to equal. Okay, let's move on to friend array now. Friend array is basically an array of friends. Hadoop already comes with an out-of-the-box array writable implementation, so we can extend that to our friend array class. So it becomes very simple. We'll use this constructor to create the friend array. The equals method in the friend array is not that important because we are not using friend array as the key in our map output. So in the mapper program, we'll see how we will use and initialize a friend array writable object. Let's move on to look at the mapper. Here's our mapper. Our input dataset is in JSON format and we'll use text input format to read the dataset. So long writable and text will be the input types to the mapper. And we'll write a friend pair and friend array as output. The text value gets the actual line from the file, which will have a person and a delimited space and then a list of his friends. So we'll use the string tokenizer to get the person and the friends. We will then use JSON simple library from Google to parse the JSON string. In the populate friend method, we'll use JSON object to parse the JSON string, then we'll get the ID, name, and hometown from the JSON string and we'll set those in the friend object. Then in the populate friend list method, we'll add all the friends for that person to an array of friends. Once you add all the friends for that particular person, you have a list of friends for that particular person. We'll use a simple array list here called friend list, and we'll add each friend to that friend list array list. Once we have added all the friends to the friend list, we'll first convert the friend list to an array, and then we'll use that friend array to initialize the friend array writable object, like you see right here. So this constructor initialization will call this constructor right here. Finally, in the mapper, we'll loop through the friend list and we'll create friend pair, and for each friend pair, we'll write out the friend pair as key and friend array as value for the map output. Now, that is our mapper. Let's move on to the reducer. The reducer will take in a friend pair and a list of friend array as input. The logic in the reducer is simple. We will simply loop through the friends list and find the mutual friends between the list. And when we find it, we'll add it to a list and we'll output from the reducer. And once we have added all the mutual friends to the common friends list, we'll create a friend array again for the common friends list and we'll output that from our reducer. So the output from the reducer will be the friend pair that we got as the input and the common friends array as the value in the output. That is it. Our reducer is now ready. Let's now move on to look at the driver program. The driver program is very simple. As usual, we set the mapper, the reducer, the input format, and the output format. For the output format, we are going to use sequence file output format. Sequence file is used to store binary types. Since we are storing a friend pair and an array of friends from the reducer as the output, we are going to store them as binary types in a sequence file. So hence, we are going to use sequence file output format. And we have a separate lesson to learn about sequence file in the file formats chapter. So make sure to check that out. For now, sequence files are used to store binary types, and we will be using sequence file output format in our program right here. That is it. Our driver program is now ready. Let's now build this program using Maven into a jar. Let's look at the pom.xml first. As you can see, I have included all the dependencies. I'm also including the JSON simple jar, which is from Google, to parse JSON objects. So let's go ahead, right click, run as Maven build. And when you get this dialog box, for the goals, just enter clean space install and hit run. That's it. This will package this project into a jar file which we can execute in our Hadoop cluster. There you go. Maven has looked at all the dependencies, compiled all our Java files, and have created a jar file for us. I've already copied this jar file into our cluster in this location right here. HIRW workshop, MapReduce, Facebook. I've also copied the JSON simple jar file which we'll use to execute the MapReduce program. So open the README file, and in this file you have instructions to execute the program. I've uploaded this input text file into HDFS already in the location input Facebook. So let's first clear the output directory. The output directory is now deleted. Now let's look at the Hadoop jar command to execute our MapReduce job. Very simple. You're saying Hadoop jar, you give the location of the jar you would like to execute, and you're giving a fully qualified name for the driver program which you will be executing. Next, we have -libjars, and we are specifying the location of the JSON simple jar. Because, as you know, our MapReduce program is going to use this jar to convert JSON string into Java objects, which means our MapReduce program at runtime would need this jar locally on all nodes. So when you use the -libjars and specify a jar, this jar will be made available on all the nodes that are executing this MapReduce job. If you don't specify or include all the jars that your MapReduce program depends on, you will see class not found exception at runtime. We don't want that, right? So we include all the needed jars using -libjars. Next, we give the input location, which is user HIRW input Facebook. I've already uploaded the input file in this location, and then followed by the output directory, output Facebook. So let's go ahead and execute the MapReduce job. There you go. So let's wait for the execution to complete. And once it's complete, let's go ahead and review the output. That is it. Our program is now complete and it completed successfully. So now how do we look up the output? Let's do a HDFS listing first to look at the output directory. Okay, we see part R0000, which is our output file, which is good. But now let's try to do a cat on this output. Our output is not in a readable format because remember, we use sequence file output format as the output format for our program, which is going to write the output as binary types, and hence it will not be in a human readable format. So how do we read the file? Recollect what we output from our MapReduce program. We output a friend pair and a friend array. The friend array is nothing but a list of mutual friends for the friends in the friend pair. Now in the sequence file, both the friend pair and the friend array will be written as binary types. To read sequence file, instead of using -cat, you will be using -text. But this Hadoop command must know how to interpret friend pair and friend array objects. The definition for the friend pair and the friend array object can be found in our MapReduce program. So we are using the -libjars again to specify the location of our MapReduce jar file, which will have the definition for the friend pair and friend array. Simple, correct? Now when you execute this command will open up the sequence file, will look up the binary types, which is nothing but a friend pair and a friend array. It will look up the jar file to find the definition for the friend pair and friend array and call the toString method on both the objects to print the output. So let's copy this command, go back to our cluster and execute this in our cluster. So here is our output. Don and Anna have mutual friends, Pete, Emily, and John. Don and Glenn have mutual friends, Pete and Emily. This is a friend pair, and this is an array of friends. That is it. That is our MapReduce program. So to summarize, in this lesson, we solved a problem in MapReduce which was inspired by the Facebook's mutual friends functionality. It's an interesting problem because we took an abstract concept and we implemented that in MapReduce. And in our MapReduce program, we also saw how to write simple custom writable objects. Finally, we saw a little bit of a preview of sequence file. And as mentioned, you can find more details about sequence file under File Formats chapter. With that, let's wrap this lesson. See you in the next lesson.